Spending four figures on a flagship smartphone feels like financing a depreciating sports car just to drive to the grocery store. Buying a flagship phone today drains your bank account like a medical emergency. But Honor offers the exact same hardware specs for €499 with launch coupons. We track the death of the ultra-expensive flagship via the Honor 600, the physical endurance of the Asus ZenBook S14, the brutal extraction mechanics of Marathon, and the bizarre human desire to suffer through sorrows by pulling facts from tech reviews across Gadget Match, GS Marina, specialized gaming subreddits, and Android Central.
Apple and Samsung dictate the absolute pricing ceiling of the mobile market, creating a massive vacuum underneath for devices operating on tighter manufacturing margins to dominate the middle tier.
You get this, like 6.57-inch AMOLED display equipped with sub-1 mm uniform bezel. That panel reaches an eye-searing 8,000 nits of peak brightness.
Pushing an organic light-emitting diode to 8,000 nits requires fundamentally altering the pixel power distribution architecture. Organic compounds degrade rapidly under massive thermal loads, capping typical smartphone screens around 2,000 nits. Honor bypasses this hard physics limitation by pulsing the maximum current in microsecond bursts, allowing individual light-emitting diodes to cool down before they burn out entirely. Samsung's top-tier devices peak around 2,600 nits. The Honor 600 pushes 3,000 nits just during normal HDR playback, manipulating the contrast ratio of the localized pixel clusters to make the highlights pop without melting the glass.
Packing a high-density chemical battery behind a screen brighter than a welding torch sounds like carrying around a ticking thermal explosive. You're walking around with a 6,800 mAh battery in Europe or a 7,000 mAh cell in China. They shrank the logic board footprint to create interior volume, then utilize denser silicon-carbon battery chemistry. All of this power delivery hardware fits inside a device weighing only 185 grams.
Utilizing silicon-carbon anodes increases the electron density of the battery cell significantly compared to standard graphite anodes. The silicon molecules expand during the charging phase to hold more lithium ions, packing vastly more potential energy into the exact same physical dimensions.
They wrap all that power into a frame protected by an IP69K rating for crush and water resistance. Earning that rating involves surviving high-pressure, high-temperature water jets spraying directly at the device seams alongside surviving literal mechanical crushing forces. The device kind of heavily borrows the oversized camera island aesthetic of the iPhone 17 Pro. The raised circular housing uses a transparent pearlescent sheen to mimic premium materials. Borrowing Apple's silhouette acts as a deliberate tactic to trick onlookers at a coffee shop into thinking you dropped $1,200.
Forget the aesthetic. The Honor 600 features a 300 and 840 Hz PWM dimming frequency that actively prevents eye strain by manipulating the light strobe rate. Display panels cannot simply lower their electrical voltage to get dimmer without ruining color accuracy and crushing the black levels. Manufacturers fix this by rapidly turning the screen completely off and on.
Flickering a light bulb to simulate dimness sounds like a terrible way to read an article in a dark room.
Lower frequencies strobe at speeds the optic nerve detects on a subconscious level. Staring at a slow strobing light forces your eye muscles to rapidly flex and readjust constantly, causing massive fatigue and tension headaches. Pushing that strobe rate to 300 and 840 Hz outpaces human biological perception entirely. Imagine looking at a ceiling fan. If the blade spins slowly, your eyes track the individual gaps. If you crank the motor to maximum speed, the blades blur into a solid, unbroken disc. The high-frequency dimming creates that solid, continuous disc of light for your optic nerve. Hardware-level blue light reduction and a personalized contrast test accompany those motion sickness relief features.
Outpacing biological perception requires an immense amount of localized processing power. You get a Snapdragon 7 Gen 4 processor, up to 12 gigabytes of RAM, and 512 gigabytes of storage. The Pro model steps up to the Snapdragon 8 Elite and adds a dedicated 50-megapixel periscope telephoto lens. Both models feature an 80-watt wired charging system. Filling a 7,000 milliamp-hour battery in the time it takes to watch 2 short YouTube videos fundamentally alters how a user views daily power management.
Shoving 80 watts of sustained direct current into a silicon-carbon array demands microsecond-level thermal monitoring. The charging controller physically resides inside the power brick, handling the voltage conversion at the wall instead of inside the phone. This moves the heat generation away from the battery cells, preventing them from venting or degrading during rapid top-ups.
The camera system centers on a 200-megapixel main sensor, paired with a 12-megapixel ultra-wide lens. Gadget Match took the base model to a late-night bar gig with unstable lighting and erratic subject movement, walking away with highly usable video clips and sharp still images.
Dividing the available surface area of the light-gathering chip into microscopic quadrants creates a massive physics problem. Each individual pixel becomes so tiny it struggles to absorb enough photons in low-light environments. The image signal processor utilizes pixel binning. The hardware groups 16 adjacent pixels into one massive virtual pixel. Catching rainwater with 200 tiny thimbles results in spilling most of the drops, but combining those thimbles into a single wide bucket catches everything. This hardware manipulation drastically increases the light absorption rate, neutralizing digital noise while retaining structural edge data.
Moving from captured optical data to generated visual realities introduces an entirely different set of technical nightmares. The Honor 600 runs Magic OS 10 on Android 16, featuring a customizable AI button positioned right below the power key.
Pressing that physical switch triggers on-device language models or acts as a physical camera shutter. Users upload up to 3 static photos into the AI Image to Video 2.0 system, and the multimodal generation engine creates a 3 to 8 second video clip directly on the device hardware. The software dissects the static pixels, predicts the z-axis depth of the objects in the frame, and mathematically hallucinates entirely new intervening frames to simulate fluid motion.
The Android Central reviewer actually used this feature to make a fake video of their cat. The Gadget Match reviewer generated a Henshin transformation clip, but felt extremely apprehensive about the results, classifying the output as AI slop. Programming our devices to hallucinate a past that never happened carries massive societal weight. We carry 200-megapixel cameras in our pockets to take ultra-crisp, optically pure photos of our actual reality, then use local processing power to distort them into 3-second fever dreams. Generating a fluid video of a cat performing an action it never actually did fundamentally devalues the concept of a digital memory.
Focusing purely on the hallucinatory aspect ignores the deep mathematical utility of localized neural processing. Diffusion models operate by starting with static noise and iteratively subtracting that noise based on probability gradients. The device predicts where a pixel should logically move based on its training data. The moving photo eraser tool utilizes this exact same probability gradient to isolate the pixel data of unwanted people in the background. It removes the interfering object and dynamically patches the missing background plate while preserving the motion of the primary subject.
The moving photo breakout collage takes static structural layouts and embeds motion vectors side by side in a single grid. The neural processing unit maps out the geometric boundaries of the subject, isolating it from the background noise. It performs pixel-level substitution without shipping your personal data to a remote cloud server farm. Patching a background plate locally solves actual framing problems without completely replacing reality.
Executing those neural net calculations requires massive floating point operations. The Honor 600 democratizes that premium processing tier, but the PC market still charges a massive premium for a laptop carrying equivalent structural durability.
The Asus ZenBook S14 cost 129,995 Philippine pesos. You pay a severe financial penalty to acquire a laptop you can comfortably run a marathon with.
Shaving a computer down to 1.1 centimeters thick while maintaining structural rigidity dictates those astronomical retail prices. The ZenBook S14 weighs 1.2 kilograms. It houses an Intel Core Ultra 9 386H processor and a 77 watt-hour battery capable of lasting 27 hours on a single charge. Heat sinks must lie perfectly flat inside a millimeter-thin enclosure. The engineers rely on vapor chambers that boil and condense microscopic amounts of liquid to move extreme heat away from the silicon.
The reviewer stuffed this fragile thermal envelope into a backpack without a protective sleeve, threw in a metal umbrella, and ran a 5K. The proprietary aluminum chassis suffered 0 scratches. Running a 5K with an unsleeved laptop and an umbrella bouncing around inside a bag is the chaotic behavior of a person who has entirely given up on respecting expensive hardware. An umbrella features jagged metal hinges and hard plastic points. Bouncing those aggressive edges against traditional anodized aluminum for 3 miles results in a device that looks completely chewed up.
Cramming your body into crowded public transit subjects your fragile devices to extreme daily violence. A laptop bouncing against an umbrella simulates the exact physical stress of rushing through a subway turnstile or dropping a canvas bag directly onto a concrete floor. Ceraluminum fundamentally changes the atomic structure of the laptop lid to combat this specific daily friction.
Turning the outer shell of a computer into a literal ceramic shield explains the massive price tag.
Asus utilizes plasma electrolytic oxidation. They submerge the aluminum chassis in an electrolytic chemical bath and run high-voltage electrical discharges straight through it. The resulting electrical sparks physically melt the surface layer, reacting with the surrounding liquid to form a hard, microscopic ceramic skin bonded directly to the metal substrate. The process creates microscopic volcanic eruptions on the surface of the lid, growing the ceramic out of the metal rather than simply painting a coating on top. The surface resists physical abrasion at a molecular level.
Asus pairs that molecular durability with a 14-inch 3K luminous screen pushing 1100 nits of peak HDR brightness. The touchscreen capabilities function perfectly for smaller software loads like the card game Balatro. The processor easily handles extreme multitasking workflows, running multiple word processors, browser tabs, chatting apps, and video players without struggling or causing the fans to spin up loudly. Pushing heavy workloads on an Ultra 9 chip usually drains the battery in a few hours, but optimizing the processor instruction sets keeps the total power draw remarkably low.
Feeding those instruction sets requires rapid memory access channels. The machine includes up to 32 gigabytes of RAM and 1 terabyte of internal storage. The 68-watt wired charging brick fills the battery from empty in 90 minutes. Delivering 68 watts of sustained power into a compact chassis demands severe thermal throttling protocols to prevent the entire system from warping under its own generated heat.
Demanding, effortless hardware creates a bizarre paradox. We spend vast sums of money on crush-proof phones and scratch-proof ceramic laptops, then purchase software deliberately engineered to cause maximum psychological distress. The gaming industry is heavily capitalizing on digital masochism. Extraction shooters like Marathon reject the concept of guaranteed progression entirely.
Modifying server-side databases provides the structural foundation for that distress. Players drop into a hostile map, scavenge for loot, and attempt to extract at designated points. Death results in the total, permanent loss of everything carried. You face UESC bots with highly aggressive behavioral trees, shielded elites, and massive warden bosses programmed to flank your position based on line-of-sight algorithms.
Playing Marathon induces the same heart-pounding terror as walking through a dark alley while holding a bag of unprotected cash. You feel the physical adrenaline spike because the digital loss is permanent. The Gadget Match reviewers spawned near a massive land vehicle called the Hauler. Their team's destroyer tank went down fighting UESC bots. The reviewer, playing the triage healer role, attempted a manual revive and was instantly dropped by a UESC ghost. The surviving assassin revived the team, but they were wiped out by enemy players at the final extraction point.
The server tracks every item in your inventory utilizing a temporary session database. When your health variable drops to 0, the game engine sends a permanent deletion command to your specific account profile. The server instantly spawns those highly valuable items into the physics instance for other players to steal. Building an extraction shooter is like forcing Claire to build a house of cards on a table while 30 other players actively try to kick the table over.
Creating a scenario where a 30-minute raid ends in a total database wipe at the finish line requires a specific type of auditory design to keep players constantly terrified.
Translating geometric level design into lethal data changes player behavior instantly. Sprinting produces high-decibel audio waves, crouch-walking alerts nearby players within a smaller radius, dropping magazines creates acoustic pings, and opening massive doors signals your exact coordinate location to the entire map. The audio engine utilizes ray-traced sound to calculate the distance and material density between your character and the noise source, altering the frequency equalization in real time. Players navigate the map using sound as a primary radar system.
The visual aesthetic completely abandons muted sci-fi landscapes. The developers chose bold, high-contrast neon tones that reinforce the chaotic identity of the game. Bright yellows and harsh magentas make enemy silhouettes pop violently against the background geometry, forcing faster visual processing and heightening nervous system tension. The gunplay relies on 28 weapons across 8 categories, covering everything from the M77 assault rifle to the WSTR combat shotgun. Firing a digital weapon relies on hit-scan math or complex projectile physics, calculating the exact trajectory of your aim against moving collision hitbox of an enemy player.
Appending new code to those base physics models fundamentally alters the firing mechanics. Attaching a Stack Overflow mod chip to the combat shotgun doubles its ammunition capacity by mathematically altering the base integer values of the magazine variable. Equipping the overcharged lens on the V22 Volt thrower transforms the submachine gun into a homing weapon similar to the classic Halo Needler. The game engine overrides the linear projectile path entirely and dynamically adjusts the bullet vector toward the nearest enemy collision mesh.
The user interface introduces massive friction during inventory management. Items look nearly identical on screen, forcing players to hover over icons and read tiny tooltips while exposed to enemy fire. You survive a brutal firefight, hide behind a neon wall, and desperately read text boxes trying to figure out which specific medkit to inject. Soros takes a totally different approach to punishment. Housemart built a Lovecraftian roguelike focusing on the Echelon the Thief expedition to the planet Carcosa. Roguelikes use procedural generation to randomize room layouts and enemy spawn tables every single run, ensuring you never memorize the map geometry.
Randomizing the environment places the focus purely on mechanical execution and build synergy. Players control Argent de Vrage, collecting a digital currency called Lucenite to unlock permanent statistical upgrades. The combat relies entirely on auto-aiming weapons and consumable power weapons. Removing the requirement for twin-stick aiming precision completely decouples visual processing from fine motor skills.
The player stops worrying about placing a reticle precisely on a moving target and focuses entirely on spatial positioning and dodge timing. It creates a fluid, hypnotic fight system rooted completely in threat avoidance rather than aggressive accuracy.
Offloading the geometric calculation of aiming directly to the game engine allows the player's central nervous system to direct all processing power toward pattern recognition. You memorize the attack patterns of the swarm and weave through the projectiles without ever pulling a trigger manually.
The map design suffers from heavy repetition, despite the procedural generation script. Every room features different terrain tiles, but follows the exact same logical structure of fighting a horde to collect a reward. You walk in, the doors lock, enemies spawn, and you survive until a chest drops onto the floor. The self-imposed Eclipse mode adds a corruption status effect, but offers zero trade-offs or enhanced rewards for surviving the increased mathematical difficulty. A status effect usually acts as a psychological risk-reward mechanism. You take more damage, but you earn more currency. Soros breaks that loop by giving you the risk with absolutely no inherent reward attached to the challenge.
Flawed progression economies dictate player behavior with absolute certainty. Players eventually abandon experimentation entirely. The optimal strategy requires defaulting to a smart rifle with auto-aim, equipping specific health upgrades, and constantly re-rolling item drops until the perfect numerical build appears. A mathematical path of least resistance forms when the random number generator refuses to provide viable, equally powerful alternatives to the primary meta strategy.
Soros lacks memorable character rating. The world succumbs to cosmic horror due to an infection called the Yellow, referencing Robert W. Chambers. The game fails to give players enough time to connect with the dying characters. De Vrage stoically searches for his lover, Nitya, while the universe collapses around him. You cannot care about a digital lover when her narrative existence equates to 3 paragraphs of text hidden behind a combat arena.
Housemart prioritized environmental world building over emotional stakes. Narrative delivery mechanisms define the player's connection to the fiction. You spend hours reading through static text journals to understand the disaster rather than experiencing it through compelling character interactions or dynamic voice acting. Reading a dusty logbook about a terrifying infection lacks the visceral impact of watching a character actively succumb to it on screen.
Buying an IP69K crush-proof Honor phone and a scratch-proof Ceraluminum ZenBook guarantees you never have to worry about your physical tools failing you. Then you log into Marathon just to experience the sheer panic of losing everything you own in 2 seconds. You spend thousands of dollars on hardware engineered to remove all physical stress from your life, purely to subject yourself to immense digital stress.
Modern hardware guarantees success through drop resistance testing, automated cloud backups, and localized AI image enhancement. Games like Soros and Marathon strip away all of those structural safety nets, forcing players to exist in environments where their decisions carry immediate, irreversible consequences. The human brain requires a specific threshold of adversity to maintain engagement. Eliminating consequence from the physical realm creates a massive psychological vacuum that digital entertainment rushes in to fill.
Tech companies spend billions eliminating physical friction from our screens, our batteries, our commutes, our daily interactions. We crave that frictionless existence in the physical world, purely so we have enough energy left over to subject ourselves to manufactured anxiety and devastating digital losses in our free time. Goodbye.